Welcome to the Engineering Update. I'm digital editor Jason Lundberg, and in this week's episode, personal robots that won't understand human speech, extending battery life, and a quantum dot-powered laser. One of the biggest drawbacks of companion robots, and really any artificial personal assistant like Siri, is their difficulty in understanding human speech.
Wake up! Wake up! Come on!
Good morning.
Hey.
How are you?
Arnie, what's the weather gonna be like today?
It's a beautiful day.
Oh, that's good. Oh no, it's raining! You're a liar! It's not gonna be a beautiful day!
Stop whining!
And because we obsess so much over that aspect of robot aptitude, these artificial creations languish while they try to make sense over a more primitive form of communication. You know, ours. But Hiroshi Ishiguro has other ideas for human-robot interactions. You might remember Hiroshi as the co-creator of the Geminoid HI-1, an extremely creepy robotic doppelganger of him. And now, ironically, the man behind one of the most realistic robots of all time is saying that people shouldn't expect robots to understand human speech, but should instead let them do what they do best, communicate with other robots. The Japanese scientist is introducing the 11-inch tall SOTA, or social talker, which is mainly programmed to interact with fellow robots, not humans. The robot will retail for $850, and since it won't waste time communicating with humans, you'll need 2 or more robots to maximize their usage.
The batteries inside our personal electronics take a pretty good beating between the frequent charge cycles and general lack of care. On top of that, they're often criticized for being unable to hold a charge and too expensive to replace once the battery totally fails. The upside is that because batteries are a constant problem, researchers are also constantly working on ways to make them better. For example, a new type of glass, discovered by the researchers at ETH Zurich, could be the next big thing in batteries. Vanadate Borah glass, which can be used as an electrode material in lithium-ion batteries, has been a focus of these particular researchers for several years. Recently, they discovered that it could effectively double the amount of time batteries last between charges. Vanadium-based compounds have been looked at as an option for a while, but the issue is due to their structure, they become unstable after a few cycles, which doesn't actually solve any of the problems. The reason they're even of interest is because they can take more charge than current materials. The researchers in Zurich mixed powdered vanadium pentoxide with Borah in order to create a material with the same positives of the original, but a more stable structure. They believe that in addition to extending smartphone batteries by 1.5 to 2 times their current life, they could also theoretically extend the power of electric cars by allowing them to travel 1.5 times further than they are currently capable. They're also looking at alternative energy and potential energy storage options for that industry. But don't expect to see this in stores anytime soon. It could be 1 to 2 decades before it goes consumer.
Quantum dots have only recently gained traction in the consumer display market, but they were discovered back in 1981, and their utility appears to be growing. Scientists at Princeton use these semiconductor nanocrystals with quantum mechanical properties to design a tiny microwave laser the size of a rice grain. The original purpose of this project was to coax 2 quantum dots into talking to each other, a tremendous feat unto itself, and they ended up using light photons as their language. To get a handle on the minuscule size of the laser, what they're calling a maser, or a microwave laser, only a single electron can cross the dot single file. The single file line squeezes through the double quantum dot, and after crossing, they bounce off mirrors to create a beam of microwave light. What's unique about this double dot maser is that the researchers are able to produce photons at different frequencies by adjusting energy levels inside the mini laser. Quantum dots could very well be the next big consumer display technology, but this experiment proves that they could also aid in the future development of industrial light sources.
That's all for this week's video. Be sure to check in on Facebook and Twitter and catch past episodes on ecnmag.com. For the ECN channel, I'm Casey Panetta, and thanks for watching.